For over 60 years, Taurex drill bits have been used in drilling operations all over the world. Like most products in the industry, the process starts in engineering. The bit designs are created by the engineering team with a combination of a proprietary drill bit performance software and industry-standard CAD software.
Each model, whether it's a matrix bit or a steel bit, is done by our engineering group, and we can do either one at any time. These are parameters for laying our cutters out on our drill bits. We use this in coordination with our 3D CAD software to lay our bits out and lay our cutters out based on the volume of rock cut by each cutter, the cut profile of our cutters, as well as the area that each cutter cuts per revolution on a drill bit. We use this in conjunction with CAD software to create our models. And once it's completed with us in design, and we send it to manufacturing.
We join the manufacturing process for the steel bits with the mill operation.
Depending on the size of the bit, the number of blades, and all of the features that the bits will have on them, that'll take anywhere from 6 to 8 hours up to 40 hours to complete one bit. This particular bit probably will be in the machine for about 24 hours.
While the steel bits are manufactured in the Norman, Oklahoma facility, the matrix bits begin to take shape in the Taurex facility in Conroe, Texas. Matrix bits are much harder than steel bits, so they must be cast. This process starts with the creation of a graphite mold. The raw material graphite is cut to length, then goes into the lathe in preparation for milling. In the 5-axis mill, the graphite mold almost becomes a mirror image to the steel bit in Norman. Gluing the displacement plugs into the mold is the last step before forging. These plugs create the pockets for the cutters. The secret sauce for making matrix bits involves a mixture of matrix powders and binders. In the furnace, the binder is the agent that will liquefy and bind with the matrix powders to create the bit. It is imperative to keep impurities out of the casting as it cools. Taurex has a special process that ensures a successful cool down of the bit. It takes 1.5 to 5 hours for that bit to be cool enough to break out of the mold. The big chunks of graphite get busted off fairly quickly. The detailed cleanup takes a bit more time. Meanwhile, back in Norman, the steel bit is almost done with the milling process. From here, it will be shipped to Conroe. Attaching the API shank for both bits is handled at the Conroe facility. The serial number for the bit is etched into the shank before it's welded to the bit. With the shank attached, all the bits are shipped back to Oklahoma for cutter installation. The steel bits get graphite plugs installed to protect the cutter pockets, then head over to the welding station for the hard surface application. When the hard surface welding is done, the graphite plugs are removed.
Okay, he's knocking all the big chunks out, and then they'll take a small air tool and clean those pockets up in appropriate size. Those tools are specially designed for doing it.
Both the steel and matrix bits are ready for brazing the cutters into place. The bits must be preheated before the brazing begins, so each brazing team has 2 workstations and a portable kiln.
With the way our kilns are set up, this is a very efficient process because with having 2 tables with only one kiln to heat things up, while they're brazing this bit, they can have another bit sitting in the kiln getting hot, so it makes us more efficient. They're brazing each cutter individually into the pocket using a braze material. They heat it up until it melts, and they're rotating the cutter to get the braze all the way around the cutter. Once that's completed, while they keep it hot, they will add a flux material, a little powder material you see, and that'll allow it to solidify the braze very quickly to hold the cutters in place. And the gentleman that's holding the torch, he's doing the brazing. The other gentleman is actually holding the cutters in place and aligned correctly in the pocket. And he holds them there till they get solidified into the pockets when they're brazing.
With the cutters firmly in place, brazing is completed and the bits are set aside to cool before moving on to the cleanup phase.
He's taken all that extra braze material off of the bit and off of the cutters and off of the fronts of the blades and out of there so that they're ready to be ground and finished. He has to do that for each blade around each cutter, the front down through every part of the bit. Once the bits are completed, they'll sandblast them before they do a final inspection.
The clean bit now moves across the aisle to the grinder.
He's actually gauging the bit per API spec. We do that on each individual bit to make sure that the bit is within diameter and ready to go. And he will continue to do that till it passes.
Once the bit has been ground down to spec, the shank well gets a magnetic particle test.
So he sprayed the materials on there to show it up, so now if he runs his magnet over it, if there's any cracks, it's going to go to the center of the bit so we can easily see if there's any cracks.
Before moving on to the paint station, the bit gets a final visual inspection.
Not only do they do a visual inspection, he's running his hands over those cutters. He can actually feel if there's a nick or anything in there.
The paint station is the last stop for this bit before it ships out to the customer.